The DoubleZero network is a system that prioritizes increasing bandwidth and reducing latency. And all the systems underpinning how it reaches those goals are designed to facilitate exactly that. So we're going to talk about routing on the public internet versus routing on DoubleZero today. So to start out with, let's look at a very simplified version of the world. We have Singapore, we have LA, we have Amsterdam, and we have Buenos Aires down in Argentina. And we'll throw New York in here just for fun. So in this model, let's say you need to get data from New York to LA. You may think that there's a direct connection between New York and Los Angeles. They're two major cities in the United States. And you would be right. There are cables that run primarily directly from New York to LA. They may have some stopover somewhere, but those introduce very little latency when you're thinking about these systems. What actually happens, though, when you're trying to send data from New York to Los Angeles, even in the United States with very well built out connectivity and infrastructure, is that packet actually bounces all around the United States, usually before it actually manages to get to its destination. You may go down to Philadelphia, then from Philadelphia you may be routed over to Chicago, and from Chicago you may be routed over to Denver, and then from Denver you end up bouncing back to Philadelphia to go through Miami, to come up through Dallas, and eventually get to Los Angeles. And at first look, this doesn't make any sense. Why would these networks be pushing data that far out and moving it in all these different directions? And to understand that, you have to look at the economic incentives behind the public internet today. Internet service providers and network carriers are not paid based on how efficiently and quickly they deliver data from one location to another. They're effectively paid on how quickly they can get your data off of their network onto someone else's network. This is traffic routing and traffic management, and in the public internet, it creates systems that are very inexpensive to use, and it creates systems that have high degrees of resiliency, but very low performance. And for most data on the internet, that's not really that much of an issue. If you're sending a text message from Los Angeles to a person in New York, it doesn't really matter if it takes 1 second or 300 milliseconds or 75 milliseconds to get from point A to point B. The data sort of arrives whenever it arrives. This becomes more of a problem when you're looking at high-performance systems across the world, and especially distributed systems. So this is why financial technology companies and high-frequency trading firms use dedicated network connectivity, which is exactly what DoubleZero uses as well. And this is to change the economic relationship from how quickly can you move traffic off of a network to how quickly can you deliver traffic from where it wants, or it is currently, to where it wants to get to. So let's draw some network links on the board here. So in this model here, we'd have a network link from New York to Amsterdam. We have a network link from Amsterdam to Singapore. And then we have a Singapore to LA connection. And these all may be contributed by the same contributor onto the DoubleZero network. At the same time, we have another one that's just providing service between New York and Amsterdam. And maybe because they're a US-centric organization, they also have a link between LA and Singapore. So with these two network providers on this example now, we're going to add a third. That's a line from New York to Buenos Aires. And let's just say for fun, they also have a connection between Amsterdam and Singapore. So due to the way cables are routed, due to the laws of physics, all of these network links will have slightly different performance even over the same route. And compared to the public internet, which, as we've talked about, has very circuitous routing. We'll draw the public internet here. And across the public internet, you may see, we're just going to start with units of 100. These are just metrics of time that we're basing everything off of. And so as you look across these network links, we may say, okay, so this network link, which provides much more direct connection, it is significantly faster, 25% faster than what you see over the public internet. And maybe over here, it is only 20% faster than what you see compared to the public internet. whereas this provider has different performance across different network routes. And we can fill in a few more here as well. And so what you see is the same network provider may not necessarily be the fastest link between all of these different points. If you are just transiting over one provider's link, well, here you have an advantage, here you have an advantage, here you're actually not transiting over the fastest link. And this is kind of the power of the DoubleZero network. All of these links in aggregate are faster than their public internet benchmark. However, on individual segments, individual providers are going to have advantages over one another. And DoubleZero as a resource sharing network is all about routing over the fastest possible path. So if you are a validator trying to operate in this environment, you actually don't care which of these two links or which of the three links in a place you're running over. What you care about is that these are better than the public internet benchmark. But that doesn't apply to all systems in decentralized trading. If you look at MEV systems, if you look at professional traders, the difference in a 5% increase in performance between these two links here may be the difference between you landing an arbitrage transaction and you missing the market. And so as we talked about before, when you look at things like jitter and you look at latency, that shows a metric of consistency. Compared to the public benchmark here, you'll have a system where you can say, okay, all of these network links are fast enough for validators. However, this one, if I am trading on Jito, I want to make sure that my data is always moving over the fastest connection possible.